Have you ever stopped to think about how a fleeting moment can become a memory you carry for life? Well, it's not some kind of magic. It's architecture. In this explainer, we are going deep, right into the brain, to map out the specific structures and systems that create, store, and recall literally everything you've ever known. All right, let's get into it.
So here's how we're going to tackle this. We're going to approach it systematically, kind of building from the ground up. We'll kick things off with the brain's overall architecture. Then we'll zero in on the core structures that are vital for memory. From there, we'll dissect the two main memory systems, declarative and non-declarative. And finally, we'll pull it all together to see how these complex systems actually work in concert.
Okay, so before we can even begin to find where our memories live, we need a map, a high-level map of the brain itself. You can think of this as just getting the lay of the land. It's the anatomical context that's going to be our foundation for everything else that follows.
Now, to make sense of the brain's incredible complexity, neuroscientists sometimes use this really helpful conceptual framework. It's often called the three brains model, and it's basically a way of thinking about the brain in three distinct evolutionary layers. The outermost layer is the neocortex. Those middle structures make up the limbic brain, and right at the core you'll find the reptilian brain.
So each of these layers really has its own specialty. The neocortex, often called the human brain, is what handles our most advanced functions. Things like sensory perception, our cognition, spatial reasoning, and of course language. Just below that, you have the limbic or mammalian brain. This is the seat of our emotions, a major hub for memories, and it also manages motor control and decision-making. And then, right at the base, you have the reptilian brain, which runs our most primal, fundamental survival programs, the famous 4Fs: fight, flight, feed, and fornicate.
Okay, so with that general map in our heads, we can now start to zoom in. Let's shift from these broad regions to the specific structures that are the real key players in this incredibly complex drama of memory formation and retrieval. First up, the big one, the hippocampus. If memory has a gateway, this is absolutely it. It is essential for taking new information, we're talking facts about the world, events from your day, and beginning the process of converting them into stable, long-term declarative memories. Seriously, without a functioning hippocampus, that whole process just grinds to a halt.
Next, let's talk about the prefrontal cortex. You can think of this as the brain's executive suite, the CEO's office. It's what manages your working memory. That's kind of like the RAM on your computer. It's the information you're actively juggling right now. It also oversees all the planning and decision-making that's involved in how you search for and actually use your memories.
Then there's the amygdala. The amygdala basically acts like an emotional highlighter pen. Its job is to process the emotional significance of an experience, and it pays special attention to things like fear and pleasure. This emotional tag it adds can dramatically enhance how strongly a memory gets stored. You know this intuitively, right? The more emotional the event, the deeper that memory gets burned into your brain.
Now, for a different kind of memory, we have the cerebellum and the basal ganglia. These two are the masters of what we often call muscle memory. They are absolutely crucial for learning and then automatically recalling motor skills and habits. You know, everything from riding a bike to typing on a keyboard without thinking about it. So after all that initial processing by structures like the hippocampus, where do our memories actually end up for the long haul? Well, many of them find their permanent home back in the neocortex. This huge, wrinkled outer layer is the long-term repository. It's where consolidated memories are stored and then later retrieved from, with different areas specializing in different kinds of data. So visual memories might be in one place and auditory ones in another.
And all of this brings us to a really fundamental distinction in how we think about memory. See, it's not just one single thing. It's really divided into two major types. On one side, you have declarative or explicit memory. This is all about conscious recollection. On the other side, you have non-declarative or implicit memory, which just hums along in the background, operating automatically without you having to think about it at all.
So let's start with the memory of the conscious mind. We're talking about declarative memory here. This is the library of facts and personal events that we can actively, consciously bring to mind and then describe.
And even within this conscious system, it's not all one thing. It's broken down into two distinct subsystems. First up, you've got semantic memory. This is your internal encyclopedia of general knowledge, just objective facts, like knowing that Paris is the capital of France. This system relies on the prefrontal cortex and parts of the temporal cortex. Then you have episodic memory. These are your personal experiences, the episodes that make up your life's story. Recalling what you did last weekend, for example, depends on the hippocampus, the medial temporal lobe, and the neocortex all working together.
All right, now let's flip the coin and turn to the other side, the vast, kind of hidden world of non-declarative memory. This is the memory that shows itself through our actions, through performance, not through any kind of conscious recollection. This is all about knowing how, not about knowing what.
This implicit system has 4 key subtypes. First is procedural memory. This is our memory for skills and habits, and it relies on the striatum, cerebellum, and motor cortex. Next is something called priming. This is where being exposed to something, like hearing a word, makes you more likely to use that word again soon, even if you don't realize why. That's a function of the neocortex. Third is associative learning, like classic Pavlovian conditioning, where you learn to link different stimuli together. This involves the amygdala and the cerebellum. And finally, there is non-associative learning. This is all about how our basic reflexes change with experience, like habituation, where you start to tune out a constant noise, or sensitization, where you become more jumpy after a scare. These operate through our fundamental reflex pathway.